All right. Looks like they're closing the doors. That must mean it is time to get started. All right, so my name is Matthias Wolnick. I'm a program manager in the file server team. And I'm going to talk to you guys about dynamic access control and data leakage prevention. This will be a deep dive, as in I will go into some interesting technical details, and I am very flexible to take it in many different directions, as you guys are interested in. I will likely spend a lot of time doing demos of one sort or another, but this is a good thing. So if there's a particular direction people would like to see, we can go into that direction and see some interesting things there. All right. First things first, how many people know something about dynamic access control? A portion, but not everybody. All right, so we're going to do a quick intro of what is dynamic access control, why we care. We're going to understand how some of these things work underneath, and how this all ties together for what we need. Now, in general, when it comes to dynamic access control, we have four big sections that we always talk about. We talk about data classification. We talk about it being important that we understand the kind of data that we have. If we don't understand the kinds of data that we have and where that data might be located, et cetera, it becomes very difficult to protect it in some form or another. We talk about encryption. We talk about how do you protect that data once you understand what's important and what's not. How do you encrypt it correctly? How can you use automatically with as little impact to the end user as possible? We talk about access controls. Access controls that are more flexible than what we're used to. So things where we don't need to rely so much on groups and the complexities that come with groups and the limitations that come along with it as well. And we talk about the fact that auditing is a primary activity whenever it comes to something that might be related to compliance. Without auditing, it is very difficult to show that you're compliant to anything. So we need to worry about auditing. And the question then comes up is, how do you make auditing manageable? Auditing is one of those things that's difficult, complicated, and I'll show you some things. But these are the high-level four big areas we talk about when it comes to dynamic access control. So we'll start with one of the more big, complicated topics, expression-based access. The reality is, if you look at access controls that we have in older versions of Windows, we basically have the concept of groups. Groups, and you can always say for any one file, people from this group, or from this group, or from this group, or from the fourth group have access to the data that's in my folder, in my share, whatever it may be. But there are some fundamental things that are missing there. Yes, the group describes the people, but group membership is sometimes tough to manage. As everybody knows, the person with the most groups that they belong to is usually somebody who's been around with the company for a very long time. Those are usually the really important execs, that kind of thing, because they've moved from part to part in the company, and it's really hard to remember, oh, he left that team. We should remove him from these 5 groups, but not these other 2, because he might need them in his new job, or he might still need them for transitioning purposes for a while. It becomes difficult. But if you broaden the concept of groups, you can basically talk about claims. What claims can a user make about themselves? What do we know about the user? We can use that information in a very constructive way to decide if someone should have access. Do we know if he's a full-time employee? Do we know which department he's a part of? Do we know which cost center he reports into? Those are the kind of things that really move well and are well structured in an organization, because HR is very focused on them and trying to keep those clear and useful for their own purposes, which means they're information that we could use for security purposes as well. When it comes to devices, in the same kind of concept, we understand the devices. We understand what they are. We understand who they're managed or not. Using the information we know about devices for access control is a very powerful concept, because we can suddenly say, well, if it's not a managed device, you don't have access. Only use managed devices. That's a good thing. And if we know something about files, if we know how to classify them, what the properties for those files are, then we can use that information to make decisions about who has access to top secret information, or public information is accessible to everybody. That allows us to then create an access policy that combines all of these into something that is effectively a nice expression that can be evaluated for access and tends to be true for large chunks of a company. Now, when it comes to dynamic access control, we look at a few things. We talk about the user and device claims. I'll show you how those things work and how those get structured into things. Expression-based ACEs. Basically the concept of taking the existing ACL system with its individual ACEs, saying, used to be member of this group, and extending that to have an expression. We talk about classification capabilities and what we can do and what we can do out of the box, what we can do with partners. We talk about central access and central audit policies, as I said. Expression-based access that utilizes user claims, device claims, resource properties. These are things that oftentimes give you statements of access that are true for a division or for the company. Only full-time employees have access to high secrecy information. We want to be able to define these things centrally, not on a per-share basis. Because if you can define them centrally, it makes it much easier to audit things, because I can say that right there in the central location. And of course, when it comes to access questions, always the big problem is, how do you deal with the fact when somebody does not have access to a share, a file, etc.? For that, we have access denied assistance. Now, unless people really want to see it, I'm not going to demo that last one today. I should be going through just about everything else, though. User and device claims. Before Server 2012, before Server 2012, the only thing that you really could make a decision on was whether a user was a member of a group or not. You really couldn't go any further. You could have, it was difficult to maintain these groups, transform them as you go beyond trust boundaries, and there was no real concept of using the device information that we already had as part of that. At least it was very, very difficult. Now, in Server 2012, we extended the concept of the user token to include user claims and device claims. Now, there's already been a concept of user claims out there for a long time. This is not something that we just came up with real quick here. But effectively what we did is we codified it into AD. We made it a standard part of the AD infrastructure and extended the token to do this kind of thing. These can be consumed by the standard the standard Windows security APIs for security decisions. So if the token contains them, the security APIs that Windows provides will consume them and evaluate them. They are, as it says, consistently issued across for everybody, as in everybody on the force can have claims, regardless of what client they're using. We can find claims for them based on what's in AD, and we will utilize those claims as necessary, and I'll show you how later. And the biggest thing that actually comes out of all this when it comes to these expressions is that suddenly we needed a way to do ands. In the past, you always had groups, or you were part of this group, or part of this group, or part of this group. Now what we wanted to do is we wanted to go and say, what if you were part of Group A and Group B? Or maybe you're a full-time employee and a member of group have access to secure information. Or a member of the HR department and a member of, the people who deal with disgruntled employees. So this concept of and conditional things is a very central piece to what I'll be talking about today. And the question about user claims and device claims is a fundamental part that needs to be there. Now, why is this actually important, this concept of or and? Well, standard thing, if you look at how groups are used, we usually have groups per project. It's a really common thing to have because you want to separate out who has access to project information. And if you have a large number of projects, that's pretty straightforward. If you're in a kind of company that deals with projects that cross international boundaries, oftentimes you have to deal with compliance regulations about how data is transferred from country to country. In that case, well, then we need access groups, not just per project, but per project and country. So in a theoretical example, if you have 500 projects in 100 countries you need to deal with, you'd need a lot of groups right there. That's 50,000 groups. Now, granted, it's probably not 100 countries. It's maybe 10 or 5. But still, you're increasing the number of groups you need drastically just because you need to deal with compliance issues. Now, if each one of those projects crosses a bunch of divisions, you get worse. In this example, you can go to 500,000 groups suddenly. It's not that complicated of an example. But really quickly, you'll see we end up hitting limits of Active Directory effectively, right? How many groups can a user really be a member of? By doing ands, we can easily simply go in and say, you have access to a share if you are a member of a project and you are a member of the group of people from the country group that is supposed to have access to this, and you are a member of this division. So suddenly the number of groups that you need is a much, much smaller group number. In this case, if you do the math, it comes up to 610 groups. You need 500 groups for projects, 100 groups for countries, and 10 groups for divisions, which is a drastic, simpler thing. But if we start talking about user claims, it gets even easier. We don't need groups. All we need is a couple of user claims. We need to know which project a user is on, or which projects, which country a user is part of, and which division they are a part of. We don't need any groups suddenly. That in and of itself, I can create ACLs that do exactly the same thing. If a user is part of Project Alpha, if the user is, in HR, and if the user is in the UK, that is suddenly my ACL. No more groups involved, a couple of properties that end up in a security token, and that's it. As an end result, you get a much simpler to manage system, and you have a very different experience when it comes to token bloat, which we will get to, yes. Now, I'm going to switch over to classification for a bit. Classification is one of those things that's complicated, understood. But there's a couple of common ways of doing this. One thing I'll point out is that we actually had the capability of classifying files on file servers in 2008 R2. We introduced that capability there as what we called the file classification infrastructure. But we enhanced it quite substantially for purposes of dynamic access control. So one of the basic things that we always said when it comes to classification of data is no matter how much you automate, at some point it is important that a user can make a decision. That a user can say, the file I just created is top secret. The file I just created has personal information in it. Even if it's not obvious, even if it can't automatically be determined, I know this is the case. So in 2012, actually, in 2012 and in Windows 8, we introduced the capability into Explorer to visualize and modify the classification properties of a file, assuming that the user has permissions to modify the file itself or the security of the file. The other thing we realized, if we were going to start using classification of files as part of our access decision, we wanted to start talking about, top secret files have different access rules than public files. We needed to be able to have a common way of describing files throughout the whole organization. In 2008 R2, you could define classifications, what classifications a file could have on a per file server basis. That's not good enough. To really do security around this, we have to have a central repository that explains how we describe data. So what we did is we extended AD. We extended AD to define classification properties, resource properties, in Active Directory, so that taxonomy can be utilized by all the file servers in the organization, as well as any clients that actually allow you to manually classify files. We then still have the capabilities of the file classification infrastructure to look for new data and automatically classify files based on a set of rules. Now, FCI, the file classification infrastructure, included a number of plugins, a number of ways of how to classify data, but they are all relatively manual. You can classify based on where a file is stored. You could classify a file based on some patterns inside a file. And another one that's a little bit more complicated, which we'll get to a little bit later. But this content classification capability is very nice, except for you have to figure out what your own patterns are. You have to learn what the patterns are that might be interesting for you. And we do provide some information about what might be good starting points, but we don't provide a definitive set. This is how you identify personal information. So for those companies who did not want to put that time into it, because it does take time to come up with these patterns, we worked with a number of the industry's big DLP partners that have technology to classify data, to identify things like personal information, and made it possible for them to plug in to the file classification infrastructure to provide classification properties for files that can then be used for access decisions along the way. And that's a really important thing. In the past, when we classified files, we stored the properties, we stored the properties in what's called an alternate data stream. Basically, a part of the file on the file system, but something that you'd never see under normal circumstances. But as the files moved around the system, or between machines, the properties would stay attached to the file. In Windows Server 2012, when you have properties that are defined centrally, basically for security purposes, those properties will not be stored in the alternate data stream as well, but they will also be stored as part of the security descriptor of the file itself. So those properties, if you do not have permission to modify the file, or to modify security of a file, you will not have permission to modify the classification properties that are meant for security purposes on that file. Simply because they're effectively the same thing. We're changing the security descriptor of the file itself. Of course, on the other side is, what do we do with the information once we have it? Yes, access control is great, but there's so many other things we might want to do. And we have a concept in file classification infrastructure called a file management task, which basically goes and says, if I find a file that is marked as something, say secrecy equals high, then I must do this policy, this application thing, policy must be applied to this file once I find it. In 2008 R2, the main policy we had was expiration of data, because we were focused on data management. We were focused on maintaining your data in a clean state, getting rid of data you don't want. But it does come in handy even now, because think about it. If you have a file server that's public, a customer-facing file server, and you find files on it that are, well, confidential, a file management task can go and look for files that are marked as confidential and automatically remove them from the public file server, put them in some place that is quarantined or isolated away that the admin can control, and remove them at your leisure after that. So it's still a very powerful mechanism, and of course a file management task can be customized. It can run arbitrary action. It doesn't have to be expiration date. It could be anything. So one of the things we did in Server 2012 is we made RMS encryption a standard policy that it can apply. In other words, if a file management task can identify a file as secrecy equals high, it can also automatically RMS encrypt that file. Now, to make everything a little more interesting, in 2012 we set it up so that both the classification of data and the application of the policy, including the RMS application, can happen in the background as data is being created. Now, we don't go and try to intercept all writes and all that good stuff. It gets very complicated. You end up with a lot of difficult states, and it's dangerous. Instead, what we do is we watch for a file that gets written out, wait for 10 seconds after the last write, and then process it from there. If it gets overwritten again, that's fine. We don't mind. It'll be overwritten. But we wait a few seconds and go process it right there. What the effect is, from a user's point of view, say you're in Word, you're editing your file, you save your file, everything works as you expect. Next time you open that file, though, if it is marked confidential inside, for example, it'll just suddenly be RMS encrypted because it matches a policy that was defined on your organization. So let me show you what some of this looks like, because it's always more interesting to see rather than hear. Let's see if this comes up. All right. So here we have a file server. Nothing really special about it. I have a little share here with a couple of folders on it, and my department shares here. And what I can do is I can go in and right-click Properties on any of these folders, and we'll see a Classification tab here. And you'll see that in this organization, it seems I have 3 properties defined. A country, a department, and an impact. And I'll show you how to get out to all that in a bit. But I can easily modify these things based on how these properties are defined, so I could change the human resources. I won't, because the engineering folder would be silly to change the human resources. But it's easy to do, and since I'm running as admin here, I have permission to modify all of these things. Now, it's interesting that for any classification property that can be used for security purposes, it cannot not only be assigned to files, it can also be assigned to folders. Why is that interesting? It's interesting because it gives us a way to automatically classify files based on where they're stored. If I mark a folder as engineering, for example, and I put a new file into it, it doesn't have a department yet, that file will simply be marked as department engineering automatically. If it already has an engineer has a department, it won't override it. But any properties that are defined on the folder that are not yet defined on the file will get overwritten, will get set by the location. So it gives them the ability to a share owner to go in and say, these are the defaults for all files that should be in my share. I know everything in the share is going to be secret. So let's mark everything secret by default. If someone wants to override that, that's great. But let's mark it as default. Now, manual classification is enabled in two ways. We enable it either on the file server by installing the File Server Resource Manager, which is where we configure classification, or through a group policy. That means if you take a random Windows 8 laptop or Windows 8 machine, you will not see a classification tab in your Explorer because most people don't need it. But for organizations that do, a group policy can be sent out, and suddenly that classification tab will appear. So it can be selectively enabled as necessary. Now, in the File Server Resource Manager, we have a few things that we show. One thing is the classification properties defined on this server. Can everybody read them? Anybody in the back not be able to read them? No? Good. All right. You'll notice here there's a few things defined. You see a couple that are marked as local in the scope field and a couple that are marked as global. Anything marked as local is something that was defined on the file server specifically. Anything marked as global was defined in Active Directory. And you'll see here exactly those three properties that we saw a moment ago in the manual classification tab. Now, given that we can define these things, once we have these properties defined, we can then come up with a set of rules. So here, for example, is a rule. No, there it is. Called Mark Credit Card Information as High Impact. Every rule has some amount of scope, so that you can say things like, well, it applies to this share but not that share, or this volume but not that volume, so to allow for some flexibility. And every classification rule uses a classification method. In the box, there are three. There is the folder classifier, which is the mechanism we had in 2008 R2 to automatically classify files based on their location. There's still a reason for it, and I'll get to that later. The content classifier, which extracts text from files, and the Windows PowerShell classifier. Now, let's start with the content classifier real quick. For every classification rule, we have a property that gets set by it, and potentially the value that is being set by that classifier. The content classifier requires that you specify strings or patterns that it should search for to decide if a file should be marked with the property value that is defined for the rule. Now, the way it does this is it extracts text from files using what's called an ifilter. Ifilters is a mechanism that the search indexer uses to turn files into text that's searchable. We use the same mechanism to get text out and then look for patterns in that text. Now, by default, ifilters are in the box tend to be things like text files, Office files, XML, HTML, things like that. But there are third-party ifilters that are free. For example, Microsoft publishes an Office filter pack, which extends the types of Office files that we have insight into. Adobe, Foxit, etc., produce PDF ifilters, etc. So there are a number of ifilters that help extend this. So this one here looks for 4 digits dash 4 digits dash 4 digits, so a credit card number. Okay. Now, the other thing that's important here to understand is that how rules evaluate things can be a little complicated. Because what if I already have a file that's marked as does not have PII in it? I don't care that there's a credit card number in it. It does not have PII. Maybe that credit card number is fake. Maybe it happens to be an order number that just looks like a credit card number. Do I really want a classification rule to have the final say versus what a user says? Those are the kind of questions that come up when you need to figure out how do you classify data. So for that reason, we made the rules flexible. We could say that, for example, rules will only apply properties to files that don't already have that property set. If there's already a personal information property or a department property or an impact property set on that file, then we will simply not touch it again. All right? But what if we do? What if the classification rule is more important than what the user said? Well, then we can say, reevaluate this thing. And the other question is, what do I do with the existing value? I already know that it says, medium secrecy, medium impact on it. I think it might be low impact. Do I care that it says medium now, or do I, leave it as medium? So you have some flexibility in how the classification rule evaluates this thing. Now, the other thing I'll show you real quick is the PowerShell classifier. The PowerShell classifier is interesting because what if your logic is more complicated than simply has content? What if you want to do something such as, who owns this file? Is the owner of the file an executive? Is the owner of a file frontline customer support? And should that change how a file is classified? Things like that, which have custom logic, we could use and we could build a plugin. We can build a classification plugin into FCI that would evaluate these things, but it requires effort. Talking .NET or C++, something on that order, you require some developer. But what if you know PowerShell? What if you don't have massive performance requirements? What you can do is you can go in and give us a PowerShell script that basically takes a file, the information we know about the file, and gives us back a value to set the property to. So anything you can come up with in terms of logic of how to classify files that you can turn to a PowerShell script, you can use the PowerShell classifier to evaluate files. Now, when we classify files, we actually go out and we scan the system. We scan the system on a scheduled basis, look for files that have been modified since the last time we classified the file, or files that have never been classified. In addition to that, if you set the classification setup to be running in the background, we also watch the USN journal. We watch the USN journal for modifications. Once they hit, we try to classify that file immediately. Now let's see if I have a nice file here somewhere. Private information. Hey, look, it's a fake credit card number. This will work great for my purposes. So here we have a file, a text file, which should not have any classification properties on it. But what I can do is I can put that file into my department shares, where we know we have a classification rule. Now, in normal situation, this would take about 10 seconds or so for the system to catch up, the fact there's a new file there, read it, try to classify it, etc. But this should go a little faster on the demo setup. Should. We see that because of the classification rule, it was immediately marked as impact equals high, which means now I can trigger other things off that, such as, for example, encryption, which, well, I might as well show you now. So what we can do here, so we can go back to the file server resource manager and go to file management tasks. Here we have a task called encrypt high impact information, or high impact office files. Same concept, we have a scope, we have a schedule of how often they should be run in the background, etc. But the question is, what files do we want to process? And the files we want to process in this case are simply all files that are marked as impact equals high. Don't care where they are, don't care what they do. If the impact equals high, I want to process these files. And the action I want to take is to encrypt that file. And I want to encrypt it to an RMS template that's provided by my RMS server. I could have something custom instead, but let's choose a template. And yes, these file management tasks are much more flexible than that. We can do things like figure out, let people know that we encrypted your file. We can have reports about what was done when and all those kind of things. And what that means in this case is if I take a client And I go to my department shares on my client. And the same kind of thing. I have a customer information file up here. Simple office file. Word being slow. But still the same concept that we have a credit card information in here. Credit card information, but simple, nothing special file. If that file ends up on the file server, the same kind of thing will happen. File server will see the new file, take it a few seconds, go process that file for whether it should be classified or not, reclassifies it, and then sees the policy that said, hey, if this is a high-impact file, go encrypt it. The first thing we'll do here is we see it's 12 kilobytes now. If I refresh this, hopefully. Not yet. Am I too fast? I didn't talk that long enough. It's either that or it didn't do it, which would be very sad because it did it earlier today. We'll find out in a second. It did not. Oh, no. Did I screw it up? It happens to me, sadly. It's the demo awesomeness. Anyway, point is, it should be classified as impact equals high now. We'll find out for that one for sure. If it's not, we will make it happen. It is marked as high, all right, because of the content, and should be encrypted as a result. Now, this gets us pretty good. This gets us some good situations, but it doesn't solve everything, right? We still need to talk about access control. RMS is good, but you can't RMS encrypt everything, or encrypt everything in general. Encrypting comes with overhead. What happens when your keys get lost? Who staffs the support lines, and all those kind of things. So we don't want to encrypt everything. The reason why we want to do this kind of thing and selectively encrypt is because it helps us control costs and security at the same time. But we still need to think about access. So let's look at dynamic access control in a little bit more broader manner. In the past, when we had share accessing files on a share, we had two levels of security we had. We had share permissions, we had NTFS permissions. That determined if you had access to a file or not. Now with dynamic access control, we add the third level. We add what we call central access policies. Effectively, it just extended the concept that we already had of two levels of decision to a third one. Now, how does that actually work? If you look at, first of all, you look at the share security descriptor, determine should you have access to the share based on the share's security. Then we'll look at the file or folder's security. If the file does not inherit the permissions from the folder, then it has file, otherwise we'll look at the folder. First thing we'll do is we'll look at the central access policy. The central access policy is actually, we have a reference to the policy. The policy itself gets cached on the server on a regular basis from AD, and only a reference is actually included in the security descriptor. The locally cached copy of the central access policy is actually made up of a number of central access rules. If each one of those rules gets evaluated in an OR situation, in an OR combination, if we are allowed to go on, if we are allowed to put the permissions that we want to have, then we'll go check the NTFS permissions last. So it needs to match all three levels for you to have access. Effectively, what that means is the lowest common denominator is what you get, which we'll get to again later. All right, central access policies. Any questions? Haven't stopped for any questions yet. Any questions, any directions, things I missed that I really want to see? Question? Good question. So, classification does only support Office files. No, it supports any kind of file. The things where Office files become interesting or become a limitation in place, maybe, is the inbox content classifier uses iFilters, and we have access to a set of Office files, their content. The Office Filter Pack, which is a free download, right, extends the number of Office files that we have access to. But we also have access to text files and other things, and of course you can get plugins for PDF or things like that. But we can classify, especially manually or based on location, anything. And third-party plugins may also go and do content classification of many more file types, since our content classifier just happens to use the iFilter method. Others may use different mechanisms to extract text from files. Okay? RMS is a little bit of a different story. The automatic encryption is primarily focused on Office files, but there are, once again, third parties that extend it, for example, to PDF formats. And we did provide a tool not long ago that could wrap an arbitrary file into an RMS envelope of some sort. Does that answer your question? Okay. Anything else? Good question. So I'll show you what the central access policies look like in a moment. But the question is, central access policies tend to be the kind of thing you want as a fallback, as a baseline. You want central access policies, by very definition, are things that are shared across large chunks of the corporation. Therefore, they should be things that are the bare minimum requirement. Do you have a lot of these? Do you have a couple of these? That depends on the organization, to be honest. In most cases, you probably don't have many. You have a relatively small set of them to choose from. But you may have 5. Wouldn't be unreasonable. Now, I'll show you some tricks to make that a little bit more interesting, a little bit more flexible as well. So first of all, we'll go to my DC. In my DC, I have Active Directory Administrative Center open. And now there's a node here called Dynamic Access Control. So the first thing I'll show you is for central access policies to be useful, we need to think about classification properties, resource properties, and user claims. So we already looked at resource properties on the file server itself, but let me show you that in Active Directory we have a bunch of these things available and defined. So we actually provide a set of properties in the box in AD that are disabled by default. Anything that has an ID that ends in _MS is something that we've predefined. Now, where do those come from? We spent a bunch of time after 2002 working on something we call the Data Classification Toolkit, because we didn't ship any property definitions in the box back then. What we did is we took a number of the large governance documents and said, what metadata would we have to track for files to be able to be compliant for this document? And then we took those properties back and tried to harmonize that set, extended with a couple of the common customer scenarios that we saw, and that's where we got the initial list from for the Data Classification Toolkit. Those property definitions were then put into AD for 2012 as defaults. But they're all disabled. So, but enabling those is actually, trivial. Right-click, enable. If I now go refresh the properties on the file server, it'll suddenly have a discoverability property. There's a lot of interesting ones in here. Look through them. There's some useful stuff. There's personal information in here, personal use, project, always a popular one. But once we have these defined, we need to talk about claims. So let's talk about claim types. Claim types can be defined pretty much arbitrarily, but they are always sourced from an attribute in AD for the user. That means whatever information you have in AD, you can use to create a claim from. However, I wouldn't suggest using an arbitrary attribute. Generally, the attributes that we would suggest that you use to make claims are things that are well structured. They have some kind of form around them. There's some kind of concept of how to name them instead of random arbitrary things. Sometimes that's useful, but you don't want to worry about 5 different ways of spelling the same thing, right? Things like that tend to be complicated to use later, especially when you want to make security decisions around them. So well-managed attributes make good candidates for claims generally, but you can create claims from any attribute. Now, in this case, you'll see that we have a department claim, and it is actually triggered off of, where is it? The department attribute in my organization. And this one actually has a series of suggested values. Now, suggested values here in a claim do not change what's in the attribute. What this does is it forces the UI, and I'll show you when we create central access policies, to only show those values as possible values for this claim. So in this case, it makes it easier to create policies. Now, once we have those defined, what we can then do is we can go in and define a central access policy. In this case, we have a single central access policy already defined, a Contoso central access policy, which is made up of 2 rules. Every central access policy is made up of 1 or more central access rules. Why is that important? Because you can have rules that are shared between policies. Everybody should care about high secrecy handling. All my policies must. Therefore, we're going to create one rule for that, and it gets shared by all of my central access policies. So for example, here we have a department access rule that basically says, I only apply to things where the resource I'm accessing has a department property. Of course, I can show you what that looks like. We can basically go in and say, resources, the classification properties that we've defined exists or has a specific value. After that, it actually becomes very similar to the ACL editor itself. As in, we can go in and say, well, what permissions do I want to have? We can look at, for example, something like this, where we say authenticated users have access to files that have a department property if the user's department property happens to be equal to the same as the file's department property. And of course, this is based on the claims that were defined and the resource properties that were defined. But you'll note that we can look at all kinds of other things. We can have various combinations to create an expression layer. More interestingly, of course, we can create a series of conditions. And no, there is no strict limit of how many you can have. We probably wouldn't suggest that you create expressions with hundreds of conditions, but you could. Be aware that the more complex the expression is, the longer it will take to make a decision when access is requested. It won't take long, but it'll take longer, and things add up. Now, once I have this kind of central access rule defined, it can add to a central access policy. And I'll get to the proposed permissions thing later. And then when I go to the file server, I can go in and I can go to Properties, Security, Advanced, and I'll see a Central Access Policy tab. This tab does not appear unless there are central access policies in AD, and group policy will push these out to file servers. Until group policy pushes them out to file servers, there will not be a tab for that here. By default, this will say nothing, but you can easily change it and set it to one of the available central access policies. And you can immediately then see what the rules are that make up this policy. Now, I should point out that I can define conditional ACLs. Users on the local file system as well. There's nothing that prevents me from doing so. So you can have multiple levels of expressions if you really wanted to. But central access policies have a certain usefulness there. Now, what does that mean? So if I now take my finance folder, which I believe, let's see here, is marked as department equals finance. And we saw the department policy earlier. And then I go to a client, where we can run the fun who am I script, which tells me that I am an operations person. That means operations, I should have no problem accessing. But finance, I don't have access to because of the department thing. Now what? Well, we talked, access denied assistance allows us to create custom error messages for access denied for a machine or on a per folder basis, including the ability to say this share or this folder is owned by someone and allow the user to request access from them. Yes, we allow links to be created as part of the error message. And when you click request access, you can provide reasoning why you wanted it. An email will be sent to the owner saying, in this case, Tim wants access. So what the owner can then do is go back to the file server and can say, okay, Tim wanted access to the finance share. Let's go look at the effective access of Tim. So I'll type in Tim, and I'll say, what access does he have, and what does he not have? And I'll see he has no access whatsoever. And it's all because of the department access rule, which we can see is a central access rule, and certain ones he's limited because of the file permissions as well. Well, the email that the share owner received included information about what claims the user has. And we can look at what the central access policy is, which we just saw a moment ago. So we can do things like, for example, say, what if he was in department finance. Well, then he would have a bunch of access, actually almost all the right access that we want. So we can experiment, put him in different groups, give him claims, give him a different device, and see how that would change his access to determine what the right next steps are. Is it to add them to an exception group? Is it to tell them you're in the wrong department and you need to find some reason why I should give you access in the first place? Is it, well, you didn't join the right group when you transitioned from role A to role B? But now we have a tool to help us figure out what's going on. And yes, this is even accessible programmatically. So if you wanted to write a tool that were to play with this, you could. So that's central access policies at the high level. Now, how do they really work? Let's assume that we have two properties on the file being accessed: engineering department and sensitivity equals high. And we have share permissions that say everybody has access, can do whatever they want to, which is pretty common. A central access rule that says for anything marked engineering, engineering has modify, everybody else only gets read. Sensitive data rule that says sensitivity equals high, only full-time employees can modify the file. The sales rule, et cetera, et cetera. I won't read them all to you. And we have three people: an engineering full-time employee, a vendor, and a salesperson. Now what happens? The first thing we do is we evaluate the share level permissions. Everybody has full access. Let's go for it. Good. Then we look at this first central access rule. And we find the engineering full-time employee matches the department. Well, the file matches the engineering department, so it does apply to the file. We have an engineering FTE, therefore he has modified permissions. Engineering vendor, another engineering person, so we have modified permissions. And a salesperson who only gets read. Because of the sensitive data rule, the vendor has no access whatsoever. But the sales FTE, both FTEs should have modified permissions. The third rule is only applicable to files that are marked as sales. Therefore, it is ignored completely at this point. And the NTFS permissions basically say, well, we have another conditional expression here. Full-time employees modify. Vendors can only read. Therefore, we get modify for FTEs and read for the vendor. What comes out of that is we take the lowest common level of access for all these various rules to determine what level of access they have. It means the vendor has no access whatsoever, while the engineering full-time employee gets modify and sales only gets read. So we combine the different levels by looking at the lowest access possible from all of them. Now, one of the big things, of course, is central access policies are great because you can define them centrally and everybody else follows them. What happens when I change it? What happens then? Doesn't that get complicated? What if I want to roll out a new one and force people to use this instead of their existing ACL system? Now what happens? Rebuilding this, that's difficult, it's expensive, it's hard. We don't want to do it. But we have something we call the staging policy. Now, I don't remember if I have a demo slide here or not. Oh, here, actually we do. A staging policy basically says, we know what claims we have, we know what resource properties we have. Those don't affect anybody when I create them. And we know what the central access policy is that we would like to have. We don't know what its effect would be. Well, we may have an existing central access policy, or we create a new one that we just don't know anything about. So we can create a new staging policy inside the central access rules and say, this is my proposed policy. What will happen then is every time somebody does not get access when they would have gotten access, what happens is every time somebody gets access when they would not have gotten access under the new rule, an audit event is logged. So every time the access is different in the new rule than the old one, an audit event is logged. What that means is now we can see exactly who tried to access something that they weren't going to be able to anymore, and how often it happened. Effectively, we can try it out without impacting people. If we're comfortable with what we're seeing, good, we'll just keep going. Hey, look. Please. So audit logs are generally stored in the security audit log, right? But the big problem with audit by default is you have too much information. All right, it's too big. Now, those audit entries are identifiable. They have an ID and all that good stuff. Makes it relatively easy. But because they're targeted, they only happen in certain circumstances. There shouldn't be that many of them usually. And yes, you can. the audit system itself, we're using System Center, etc., allows us to gather all the audit logs together into one central location, so we have one place to look at. Does that make sense? Now, really fast, I'll do a quick demo here of what this looks like. On the DC, go back to the central access policy, central access rule. You'll see down here we have proposed permissions, just like we have right above it current permissions, which allows us to create a staging configuration which copies the exact same configuration as in the current proposal, the current situation, and we can modify it from there, make our own changes. As a result, we end up getting a nice audit log entry whenever this is not as different. So relatively simple, nothing complicated to configure. So what does it look like? Here's a sample event. So ID 4818. And it's relatively simple. It tells you who tried to access the file, what is the file that they tried to access, what is the current policy, what do they currently have access to, and why do they have access to it, and how would it change if the new policy was applied. So it has exactly the information that kind of things that you'd want to find out to analyze if the current proposal is a good one that is acceptable for your organization. Now, Kerberos. Important stuff. We do leverage Kerberos. There's no question about it. When we talk about device claims and user claims, we start talking about compound ID. What we've effectively done is we've extended the token. The token in the past has your user account, has your groups, but now we've taken it further. For users, we also store claims in the token. If you use device claims, device groups, we also put those into your token if compound ID is enabled. The domain controller generates these things as necessary, as requested. And we now provide these things simply as token. And yes, I will get into token bloat. There is a slide on this. And we have another 23 minutes, so we're in good shape. So how does this thing work? How does this whole flow thing work when I have access that's being requested when it comes to Kerberos? So in general, an AD admin goes and tells the DC to start issuing claims. Defines user claims, defines device claims, says this needs to start happening. When the user then attempts, once they've defined their claims, of course, the user attempts to log in, they get back the Kerberos ticket with user groups and claims, and sends those to the file server whenever they attempt to access the resource themselves. Now, how does that work, before 2012? So the user would go to the DC, he'd get back a TGT, a machine TGT. He then goes back and requests the user TGT, which then comes back, goes and gets the TGS for himself without any claims, and provides that information up to the file server to say, okay, do I have access or not? With Windows 2012, the same first couple steps happen. We still get the machine ticket granting ticket. We still get the user ticket granting ticket. But then when we go and request the TGS from the server, we get back one with user claims, which then passed up to the file server, just like before, and the file server makes a decision. What if I don't have a Windows 8 client that knows to go and request user claims from the DC? Well, first thing that happens is when the DC defines claims, when there's claims defined in Active Directory, any file server that uses claims for a central access policy basically says, okay, I know I use claims, make sure that this is all enabled. So the DC pushes out to the file server, saying here's central access policy, you're going to be using claims from now on. When the Windows 8 user then goes and tries to get the TGS, it comes back with the TGS without claims because it's a non-Windows 8 user. He sends that information up to the file server. The file server says, I know I need claims. I have these new ACLs, I need claims. And we'll go to AD on behalf of the user and request a TGS with claims, and then make a decision based on that. That means this is what happens with a Mac, this is what happens with Linux, this is what happens with Windows 7 and XP. It will work just fine, and the decision will be made by the file server should you have access or not. One limitation here is that the file server can ask for claims. Actually, I have slides on that. I just realized. We'll get to that. What about compound identity? Right? Compound identity, machine claims. With Windows 8, same kind of thing as before. We get back a TGS with user and device claims, and groups, of course. And provide that up, and the file server says, OK, you have access or not. Don't I have one? I thought I had one. With a non-Windows 8 client, the file server does not know anything about the machine that you're using to access the data. That means the file server cannot request machine claims on behalf of the user. You can ask for user claims. That's all the file server really knows about. Which means if machine claims are required for access purposes, and you're using a non-Windows 8 machine, well, you're not going to get access to that file because you can't provide those claims because it doesn't have them. Now, what happens when there's multiple forests involved? Well, so we have the concept of a cross-forest transformation policy so that we can transform claims from one forest to another. We published the fact that the trusted forest has this kind of transformation policy. And when we go and request the TGS, et cetera, from our AD, we get back a referral TGT instead. The referral TGT then gets passed on to the trusted forest, which brings us back a TGS with claims, which we then, of course, pass on to the file server. Lots of fun pictures. Now, how does this work with the cloud? ADFS. This is important, right? Same kind of concept. We get back a TGS from AD. We send the TGS to our cloud app. The cloud app says, I don't know what to do with this. So what we do instead is we send the TGS up to ADFS. ADFS brings us back a SAML token, which we can then pass up to the cloud app and give us access to the file or not. Any questions? Lots of, please. Device claims. Sure. Uh-huh. Mm-hmm. Mm-hmm.
In Windows 7, you can see your claims. If you use appropriate Active Directory policy.
So the claim is that you can use claims from a Windows 7 PC and not have the file server get claims on your behalf. And that whoami/claims would tell you this on Windows 7. The thing is, I don't think we support the /claims option even on whoami in Windows 7. I'm pretty sure we added that in Windows 8. I'd love to talk to you about it because I'm a little confused. It shouldn't work. How's that? For that matter, by default, if you don't have functional level in AD, as in all DCs run Windows Server 2012, even though Windows 8 client will act like a Windows 7 client and not go request claims initially, we'll let the file server go request claims. And there's a reason for this. And yes, it's a little bit technical detail, but it's good. When you want to deploy this thing, when you want to deploy resource property definitions in AD, you need the schema. When you want to deploy claims, you need enough DCs to service the request. Only 2012 knows to service the request, or knows to answer the requests for claims. If you have 2 Windows 2012 DCs, and you have, say, 1,000 others, if all your clients suddenly started pointing to those 2 machines, you'd have massive overload on those 2 machines. So what we do is we assume that since the connection are cached effectively when you go to a file server, we assume that there will be less requests if the file server does it for you than if all the clients on login try to go to the 2 Windows 2012 DCs. So the file server will go and make that request for you, even if you're using Windows 8 as the clients, unless you're at functional level. In other words, all your DCs are 2012. then the Windows 8 clients will go directly and get the claims on login because it's safe. I'd love to actually look into this a little bit because I'm curious to see what you're saying. All right. Got 15 minutes, and we have a little bit more to go. Token ticket bloat. Yes, we're worried about it. We know we're worried about it, so we need to figure out how do we deal with it and what is there. First of all, we need to understand how much are we going to bloat the NT token and how much data is going to get sent over the wire by using the tickets. And how do we bound this? What should we expect as we go along? We know that there's a limit in the number of SIDs, right, in a token, so we have to be careful about that. And we have to watch that we don't slow down things and we don't make people suddenly have no access to anything because we hit limits, which is always a bad thing. Now, when we add claims, into the system, we don't expect people to drop all their groups tomorrow. It just won't happen, right? You can't transition from one system to the other overnight. As a result, it is expected that during the transition period, the token will increase in size because we're putting claims into your token and you still have all your groups. As time goes on, we expect that to shrink again because you can start removing groups from your system, at least some of them. So as a result, we had to deal with some of that. So in Windows 8, we made some rather significant changes there. We started compressing claims before they put into the token. We compress certain types of SIDs that help us reduce the string, and we changed the max token size by default to 48K. We also add a bunch of audit events that tell us when you're about to go and blow past the limits that will cause you all kinds of pain. We don't want to do that, right? Now, real numbers. The first claim, adding a single Boolean claim into the token, adds 242 bytes. There's some overhead because we have user sections, we have the device section inside the token. We have to have an individual Boolean value. Isn't big. It's 8 bytes, big deal. But if you have a claim itself, there's some overhead associated with it. If you have a string claim, well, we're going to add as much data as necessary to maintain the whole string in your token. That means 2 bytes per character. So it adds a bit of overhead. Now, what does it really look like if you have something a bit more realistic? Say we have a Boolean claim, we have an integer, we have a couple strings, 3 strings or so. And with some averages there, we see about 970 bytes added. So it's not huge. But remember that our 500, 600, 700 groups that we had, right, which started out as 500,000, turned into 3 claims. So we shouldn't really expect large numbers of them. Now, compound ID gets a little bit more complicated because, well, the device adds overhead, and the computer the device comes with its own groups as well. So we add a bit more information here. So if you add another Boolean, another string claim on top of it, we add about 1,400 bytes of claims data, and of course the computer's groups data as well. So we do add some overhead, but worst case analysis, no compression. We find that we should not expect, this is all worst case, right? We should not expect massive increases in token size, even without the compression that we have enabled on the system. So that's good. This is good. Token bloat, short-lived problem. It's not that big of a problem in the first place. Now, deploying this thing is actually questions before I go to anything else. Anything? No? All right. Oh, on the back, please.
What kind of performance increases do you produce? So do you not need more ECs about performance of the server?
So the question is, what kind of performance implications does all this have? There's a couple of levels. You have some additional overhead because you're transferring more information in the tickets, right? That is overhead. In terms of the actual access evaluation, it's negligible, as in you should not notice it unless you have very complex expressions. And by very complex, I mean, dozens and dozens of conditions. You should never see a difference from a normal access request evaluation. There are other implications by automatic classification. That does have an impact on the file server itself when you're automatically scanning for data, but it's usually a short-lived impact. It doesn't stick around for a long period of time. Does that answer your question? Okay. Please.
What is the lifetime for the ticket that is set up after?
Unchanged, so it's the connection. I think it's a connection and there's a timeout as well. I'm trying to remember what the timeout is, though. It's, I don't remember off the top of my head, but there's a standard timeout even today. It's unchanged from previous systems. Sure. All right, and real quick, deployment. You don't have to go whole hog and get everything up to 2012 on the server side and all the DCs upgraded to 2012. It's not necessary. You can take things step by step. One thing I haven't shown you yet is audit. Maybe I should show you audit. It's actually kind of interesting. Real quick, just because it's kind of fun. One of the basic things that we usually do when we start deploying something like this is we say, okay, so what's out there? I don't know what there is. We know we can do staging policies, but that doesn't necessarily give me everything I want. So one of the things we can do is I'll show it to you on the file server side first. Okay. I'm going to go back to security for the folder. And you'll notice that there's an audit tab here as well. What I can do is I can create a new audit policy for a folder saying all authenticated users that try to access data on this folder that attempt to, well, read sounds good. Where the user is, let's say, he is part of the, well, equals engineering. Well, even better. Device does not equal the resources department. So we have cross-group interactions. We want to understand when that happens. So I can start this. I can set this up, and instead of logging every file read that's out there, it will only log the file reads where somebody successfully accessed a file from a department that is not their own. So instead of getting a mass quantity of data, which is the common problem with file system auditing, we can target our file system auditing very specifically to the events that we care about and the situations that we care about, effectively making it a much smaller haystack to search. Now, while it is cool that we can do this on a per folder basis, we can define this as a global audit policy in group policy as well. So if I go to GPEdit, which should be interesting if this works, GPEdit, interesting. There we go. GPEdit. All right, and then go into, where is it? Windows settings. It comes up. Security settings. Advanced audit policy configuration. System audit policies. And then we have, oh, where is it? Global object access policy. I can change, enable the file system policy auditing, define this policy setting, and I can do exactly the same thing I just did on a local machine and push a policy like this out to every machine that I care about in an OU, in my domain, in my forest, and say, let's gather all this together. And once again, use System Center to gather all of it into one place so I can go analyze this thing and understand what's out there in a much more concise way instead of having to dig through audit logs for the next 2 years. But audit policies, staging policies, make it very easy to start thinking about how do I deploy dynamic access control in general. Classification of files. All you really need is a 2012 server. To do security policies around the classification of files, you need a single DC minimum. But you don't need to go whole hog. Once you have a bare minimum number of DCs, you can define user claims. You can make policies based on user claims. You can push these things out throughout your organization. And with Windows 8 clients, we can add device claims into the picture. We add access denied assistance into the picture. And as we get to functional level, the whole thing becomes even easier. And yes, there are a whole number of partner solutions that enable this thing in a much simpler manner for specific verticals. They provide automation for things. So for example, there are partners out there that help analyze your existing ACCOs and suggest ways that you could turn them into central access policies and monitor the transition, or that provide ways to classify data in more interesting ways. And one of the important things to note is central access policies being defined in Active Directory could be enforced by anyone, but are enforced by the file server in Windows Server 2012. That means, in theory, SharePoint could. That means databases could. That means a filer could. Anything could. But they don't always. And yes, there are partners working on extending central access policies into other workloads, such as SharePoint. So that not just the file server will enforce them, but as data flows other places, that policy will enforce further. Please. There are partners looking at those kind of questions, yes. I don't know exactly where they are right now for big filers. To be fair, the right place for a big filer, like NetApp, EMC, etc., really to respect these policies is for them to do it natively. Right? Anything else is an add-on, which means an extra layer of something. But still, that means there are partners that are working on this kind of thing. Specifically, there are partners working on translating central access policies to XACML, which can then be enforced by other things. So there are at least 2 partners working on exactly that, and they have shown their capabilities to translate central access policies into XACML. So, in summary, what's the purpose of all this? We want to reduce group complexity. We want to make it easier to manage your access control in your organization. We want to enable information governance on file servers. All this gives you ways to do compliance, do information governance on the data that's on your file servers, which tend to be massively opaque boxes from a compliance point of view. There's mass quantities of data, and we're going to spend the first 5 years analyzing what's on them for the last breach that we had and to try and be compliant and minimize our losses. This helps you save yourself time, save yourself money, makes audits so much easier, and really enables good information governance policies. And of course, implement effective access control. Not something that changes over time, that used to be really good, but 3 years later is no longer quite as good because half the company has access to data after all, even though they shouldn't. All right, so yes, surveys are great, but now we have time for some questions. Please, any questions? Please. How about PowerShell support for what? So, can you do these things from PowerShell? Can you interact with the system? Can you define things? Can you configure it? Yes, you can. Everything is accessible from PowerShell. Either there are commandlets to do so. For certain activities, such as setting or retrieving the classification for a property for a file, that has to be done through effectively a COM API, but it is accessible from PowerShell as well with 2 lines. So it's not complicated. Please. Not remote. So you're saying, I think the question is, can you somehow say, there's a share, for example, that should only be accessed locally, not remote. Is that right? Did I get that right or did I get it wrong?
Yeah, if you have a storage department, they could choose to move this log, for instance, into Azure. But I need to be sure that this data is local.
Stays local. Okay. Okay. Got it. So if you have data that's marked as high sensitivity or contains PII, is there some way of preventing it from getting moved, say, to Europe or out of Europe, for that matter, right? Or into the cloud? And the answer is, it depends on the mechanism that you're using to move the data. The mechanism that moves the data could utilize the properties that's there. Will it? That's a different question. There's nothing blocking a copy right now, for example, because that would be, well, that would limit your access to the thing completely, right? Copy and read are the same thing, right, in terms of access control. But yes, it's theoretically possible that the mechanism you use to sync or to replicate or whatever else you do, to notice the fact that something is marked as PII and not move it therefore. It's theoretically possible. It depends on the mechanisms you're using. That doesn't mean I necessarily know exactly one that would do exactly what you want, but it is theoretically possible. Okay? Any other questions? I think we are out of time officially, but...
Are there any partners that you announced basically also at the event?
We have, are there any here? I don't know if there are any here, to be honest. I didn't see anybody. I didn't see any of them here.
Can you give us a name?
There are names. We can provide some offline as well, yes. And if you go to the Microsoft partner site, you should be able to search there as well. They should all be listed there as well. Okay? All right. Thank you very much. I appreciate your time. Hope it was interesting and not too horribly boring.